Jai Hind to everyone. My name is Mili Srivastava and today I am going to discuss about disk scheduling in operating system. So first of all, what is disk scheduling in operating system? There are a lot of disk scheduling algorithms, and in which first is magnetic disk is a storage device that is used to write, rewrite and access data. So there is some particular architecture of disk scheduling algorithms, that is the entire disk is divided into platters, as we can say in this diagram. We see that this is a disk, and this disk is divided into some platters, or we also known as tracks, and each platter consists of concentric circles called as tracks, like this. These track divided into some sectors. These are particular sector, like this is one sector, this is second, third, fourth, and this disk divided into some sectors. This is called as disk sectors. Now these tracks are further divided into sectors, which are the smallest divisions in the disk, a cylinder, and after that when we divide this track into these sectors, and after that we make a this type of cylinder, in which a cylinder is formed by combining the tracks at the given radius of a disk pack. So this is example of magnetic disk, how it works. Now in magnetic disk, we can say that magnetic disk is a device that is used to write, rewrite and access data. It is used as magnetization process, and this is very useful and important part of operating system, by which there exist mechanical arms called read-write head. There is a read-write head exists in this part, which is called as mechanical arm as read-write head, and now it is read from the write to the disk. Head is to reach at a particular track and then wait for the rotation of all the platter. The rotation causes the required sectors of the track to come under that heads. Now each platter has two surfaces, that is top and bottom, and both surfaces are used to store the data. In the both surface, like top and bottom, we basically magnetic disk is used for storage of data. Now each surface has its own read-write head. Now this is diagram of magnetic disk. As we can say that there is read-write head. This is called arm assembly, in which we can hold all the disk like this manner. This is tracks, in which there are some sectors divided into this, and with the help of one spindle, this is called a spindle, they all are tied together. So we can say that this is some type of disk scheduling manner or diagram. Now in this part, when we use this, there is some rotational causes that require the sectors of the track to come under the read-write operation in the head, and by each platter two surfaces, we can say that there are two surfaces, that is top and the bottom. Both surfaces are used to store the data. Now this is one of the main important part of disk scheduling. Disk scheduling is a technique in which we can say that technique used by the operating system to schedule multiple requests for accessing the disk. So there are some disk scheduling algorithms, that is the algorithm. What is disk scheduling algorithms? The algorithms which is used for disk scheduling are called as disk scheduling algorithms. Now the purpose of this disk scheduling algorithm is reduce the total seek time. So there are some disk scheduling algorithms such as FCFS, first come first serve algorithm. Second is SSTF. Next is scan. Now CScan, look and CLOOK. There are 6 disk scheduling algorithms. Each algorithm has its own characteristics and its own importance. So what is this? this is dish scheduling. There are some parameters like seek time, rotational latency, data transfer rate, control overhead, queuing delay. These are some parameters by which we can solve the problem of dish scheduling algorithms, and the time taken by the disk to complete the input output request is called the disk service time or disk scheduling disk access time. So with the help of these parameters, we can identify that by the help of these algorithms used for dish scheduling are also called as dish scheduling algorithms, and the purpose, basically the purpose of dish scheduling algorithm is to reduce the total seek time. So what is the main purpose? Purpose of to calculate what is the total, reduce the total seek time. Now these are some definitions. Seek time. So what is seek time? The time taken by the read-write head to reach the desired track is called as seek time. So what is seek time? The time taken by the read-write head to reach the desired track is called the seek time. Now it is component which contributes the largest percentage of the dish service time. Percentage of the disk service time. The lower the seek time, the faster the input output operation. This is the main important point. The lower the seek time, the faster the input output operation. Now rotational latency. What is rotational latency? The time taken by the desired sector to come under the read write head is called the rotational latency. It depends on the rotation speed of the spindle. So this is also very important. It depends on the rotation speed of the spindle. Now data transfer rate. What is data transfer rate? The amount of data that passes under the read-write head is given amount of time is called as data transfer rate. So what is data transfer rate? The time taken to transfer the data is called transfer time. This is data transfer rate. Now there are some scheduling algorithms such as dish scheduling algorithms. First is first come first serve dish scheduling algorithm. As the name suggests, as can easily understand, as the name suggests, this algorithm request in order they arrive in the disk queue. It is simplest dish scheduling algorithm. And there is some advantages of dish scheduling algorithm. What is? It is simple, easy to understand and easy to implement also. Now it does not cause starvation to any request because there is no any preemptive technique. There is first come first serve technique. So there is no any starvation of any request. Now what is the disadvantage of this? It results in increased total seek time. It is inefficient. Now there is some example of FCFS problem. What we have done here, there is consider a disk queue with request for input output to blocks on cylinder, that is 98, 183, 41, 121, 14, 124, 65 and 67. So the first come first serve scheduling algorithm is used here, and the head is initially at the cylinder 53. Where is head? Head initially at the cylinder 53. Now the cylinders are numbered from 0 to 199. Their head is 0 and last point is 199. So what we'll do here, the total head movement in number of cylinders in occurred while servicing request is, this is question. Now it goes from 53 to it simply works on the basis of first come first serve. So after 53 it goes to 98. Now after 98 it goes to 183. After that it goes to 41, and after 41 it comes in 122. This is, that is 122, and after 122 it will go 41 to 122, and after 122 to 14. Now after that 14 there is 124, and it goes 124, and after 124 it will go in 65. This is 65, and after 65 it will go to 67. So this is the technique of first come first serve scheduling algorithm. So now what we'll do here, as we draw this technique, after that we can say that total head movement incurred while servicing these requests, that is 98 minus 53 plus 183 minus 98, 183 minus 41, the help of diagram, 98 minus 53, 183 minus 98 plus 183 minus 41, 122 minus 41, 122 minus 14, this is this distance, and 124 minus 14, 124 minus 65, it is 124 minus 65, this distance, and when we calculate it comes 632. So this is the answer. Now what is the answer? 632. This is the answer with the help of first come first serve basis of disk scheduling algorithm. Now this is arrow diagram representation of FCFS scheduling, that is 53 to 65, 98, 98 to 183. This arrow shows towards head tail movement, that is 53 to 98, 98 to 183, 183 to 37, 37 to 122, 122 to 14, 14 to 124, 124 to 65, and 65 to 67. This is head movements of FCFS disk scheduling algorithm. Now shortest seek time first scheduling algorithm. What is SSTF disk scheduling algorithm? This algorithm services that request next which requires least number of head movements from its current position regardless of the direction. It breaks the tie in the direction of head movement. So this is SSTF disk scheduling algorithms, in which how we can solve this problem. Suppose consider a dish queue with request for input output to blocks on cylinders 98, 183, 41, 122, 14, 125, 124, 65 and 67. These are the basically blocks on cylinders, and now the SSTF scheduling algorithms is used. Here we use SSTF scheduling algorithm. Now what we'll do here, the head is initially at the cylinder number 53. Initially, where is head? Head is initially at the number of 53, and moving towards larger cylinder number on its service path. So what we'll do here, the cylinders are numbered from 0 to 99. Here is also condition, cylinders are numbered as 0 to 199. This is the range of this scheduling algorithm, and what we'll do here, the cylinders are numbered from 0 to 199, and the total head movements in number of cylinders incurred while servicing these requests. So what we'll do here, first initially we go from 53 to 65. This is in this first of all it takes measures what is the minimum distance between two heads. So 65 is the nearest point of 53. So it goes 53 to 65, 65 to 67 and 65 to 67 to 41. This distance is minimum about these distances. So it will go 67 to 14. Now 14 to 41 to 14 and 14 to 98, 98 to 122 and 100. After 122, it goes 124 and from 124 it goes 183. So what next? What we'll do here? 65 minus 53, 67 minus 65. This is step 67 minus 41 and 41 minus 14. This distance. 98 minus 14. After that 122 minus 98. And 124 minus 122, this distance, we calculate this point, and in last 183 minus 124. So this is the basic technique of SSTF. Consider there is some dish scheduling request for input output to block on cylinders which are given in the sequential form of any cylindrical cube. So now the SSTF scheduling algorithms used. Here we use SSTF scheduling algorithms. After that, so what will be the answer? Answer is 236. There is another example of SSTF dish scheduling algorithm. Here consider a dish system with 100 cylinders. The request of X is these cylinders occur in following sequence. This is the sequence: 4, 34, 10, 7, 19, 73, 2, 15, 6 and last is 20. So this is the sequence of for this algorithms in this algorithm. So what we'll do here, assuming that the head is currently at 50. What is the time taken to satisfy all requests if it takes 1 millisecond to move from one cylinder to adjacent and one shorter seek time first policy is used? So what will be the answer? So how we'll solve? Suppose there is given, where is the head? Head is at the position 50. So what is the shortest distance from 50? This is 34, 34 to 20, 20 to 19, 19 to 15, 15 to 10, 10 to 7, 7 to 6, 6 to 4, 4 to 2 and after that this is 2 to 99. Head starts at 53. This is arrow representation of this scheduling algorithm. So when we solve this question, 65 minus 53, 67 minus 65 and 67 minus 37, 37 minus 14. So when we solve this, so answer will be 236. Now, next is scan dish scheduling algorithm. What is a scan dish scheduling algorithm? There is head starts from one end of the dish and move towards the other end, servicing all the requests in between at the another end. So after reaching the other end, head reverses its directions and move towards the starting end, services all the requests in between. So the same process repeats. Now scan algorithm is called as elevator algorithm. What is the advantage of this algorithm? It is simple, easy to understand and implement, and it does not lead to starvation. Now what is the disadvantage of this scan dish scheduling algorithm? It causes long waiting time for the cylinders just visited by the head. Now it causes the head to move till the end of the disk even if there is no request to be serviced. So this is problem of scan dish scheduling algorithms, in which consider a disk queue which requests from input output to blocks on the cylinders, that is 98, 183, 41, 122, 14, 124 and 65 and 67. So the scan scheduling algorithm is used here, and the head is initially at the cylinder number is 53. Where is head? Head is at 53. Initially, head is at 53. Moving towards larger cylinder numbers on its servicing path. So, the cylinders are numbered from 0 to 199. The total head movement in the number of cylinders incurred while servicing these requests is. So, what will be the answer? You can see here there is 51 and it goes from definition we know that head starts from one end to the disc and move towards the other end servicing all the requests in between. So, it goes 65 to 67, 98, 122, 124, 183 and 199. When it comes at the end, one end of the this scheduling, then it change its direction after reaching the other end. When it will goes from one end after reaching other end, head reverses its direction and move towards the starting and servicing all the requests in between. So, it goes from the starting and in this algo, it takes all the points. So, when it reverses its direction, it goes from 41 again and 41 to 14. This is 14. So, this is the basic concept of scan disk scheduling algorithms, in which this is one how it works. This is 199, last point, 199 to 53 minus 53 and 199 minus 14. Another end. So, what will be the answer? 331. Now, this is the scan disk scheduling algorithm arrow representation diagram. Illustrate showed all head movements. Next is loop disk scheduling algorithm. What is loop disk scheduling algorithms? What will done here? Loop algorithm is an improved version of the scan algorithms, in which head starts from the first request at the one end of the disk and moves towards the last request at the other end, servicing all the requests in between. So, basically this is a smart version of scan algorithm. Now, after reaching the last request at the other end, head reverses its direction. It not goes at the last end. See here, it not covers the 199. So, it will consume time and processing seek time, latency time. So, here what we'll do, after reaching the last request at the other end, head reverses direction and it then returns the first request at the starting and servicing all the requests in between. The same process repeats again and again. Now, what are the advantage of this disk scheduling algorithm? It does not causes the head to move till the end of the disk when there are no requests to be serviced. Now, it provides better performance as compared to scan algorithms, and it does not lead to starvation. Now, we take some example. There is some disadvantage also. There is an overload of finding the end request also, and it causes long waiting time for the cylinder just visited by the head. So, we take this example. Consider a disk queue with request for input output to block cylinders on 98, 183, 41, 122, 14, 124, 65 and 67. So, now the loop scheduling algorithm is used here. The head is initially at cylinder number 53, moving towards large cylinder number on its servicing path. Now, the cylinders are numbered from 0 to 199. The total head movement in number of cylinders incurred while servicing these requests is what? So, when we solve this question, it goes initially head at 53. So, it goes from 58 to 65, which is the smallest distance between 53, 58 and 65, 65 to 67, 67 to 98, 98 to 122, 122 to 124, 183, and when it passed through 183, it reverses its direction and it goes to 41, and now last is 14. It not covers endpoints also like 199 and 0. So what we'll do here, 183 minus 53 and 183 minus 14. So answer is 299. So we can say that, or we can observe that look, this scheduling algorithm is more advanced version of scan algorithm. So in look scan look algorithm, this is we can say that this is improved version of scan algorithms. There is some types of head starts from the first end and at the end of the disk and moves towards the last request at the other end, servicing all the request in between. Then after reaching the last request at the other end, head reverses its direction and then it returns to the first request at the starting end, servicing all the requests in between. The same process repeats again and again. So this is all about the scheduling algorithms. Thank you so much.